Write the equation, slope intercept form, y equals mx plus b for the two given points. Step one, you gotta find the slope. So if you have 2 points, the slope, change in the y divided by the change in the x, change is subtraction. One step at a time, especially when a quiz is open note. So we did a warm-up that was exactly like this. So it was outlined step by step, and like the second one as well. The slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So the slope for this line would be, it doesn't matter which y you pick. If I start with 5, it's 5 minus this y is a negative 1. So parentheses negative 1 over, if you start with this y, you got to start with this x, 8 minus, this is a negative 8, so parentheses minus 8, negative 8 right there. 2 consecutive negative plus 5 plus 1 over 8 plus 6. 8 plus 8, sorry. I was giving ahead myself to the answer because it's got 6 in it. So that's a 6 over a 16. As the directions say, lowest terms. Do yourself a huge favor and simplify. I think I mentioned that. Simplify that. That's 2 times 3 over 2 times 8. So the slope is 3/8. Now, if we had started with this y, negative 1. Negative 1 minus this y, 5. Over, got to start with this x, negative 8. Minus this x, positive 8. We end up with negative 6 over negative 16. Negative over negative is positive, and 6 over 16 is still going to be positive 3/8. So no matter how you do it, you're still going to get 3/8 as your slope. So when you're trying to find y equals mx plus b, you've got to find that piece, that part M. You got to find that piece of the puzzle, that part B. You just found the slope, M. Then you say, is it a special case? Because if it's horizontal or vertical, the next step would be horizontal is just y by itself. So what does y equal? And that would have been if we got a slope of 0, which we didn't. Vertical is just x by itself because x is the same all the time. And that would mean we got an undefined slope and we didn't. So this is an actual good to go line. So we write down y equals mx plus b, at least I do, to remind myself what I'm about to do. Substitute m, y equals 3/8 times x plus b. Now to solve for b, that's the next part. You got to figure out what the b is. What's the y-intercept of this line? You have 3 variables, y, x, and b. When you want to know one of the variables, you need to plug something in for the other 2. So for these other 2, you have an x and a y, and you have an x and a y to choose from. So it doesn't matter which one you pick, no matter what, you'll get the same answer. So if I pick the first one, and I'll do it over here, if I choose to use -8, -1, that means I'm going to let x equal the -8 and y is the -1. So going in for y would be -1 equals 3/8 times x, which is -8, and then plus b. And if you look how nicely this works out, -1 equals 3/8 times a negative, positive times it's going to be a negative. 8 goes into 8 and reduces completely. So all you have is a -3 times 1, -3 plus b. So add 3. -1 plus 3, +2. So you would complete the equation and substitute in 2 for the b. Or if you choose to go with the 2 positive numbers, which is probably a better choice, the 8 and the 5, let the x equal an 8 and the y equal a 5. So going in for y is 5 equals 3/8 times x, 3/8 times 5, sorry. That's 8 times 8 plus b. And 3/8 positive times positive, 8 goes into 8 again evenly. So 5 is equal to 3 times 1 plus b. Subtract 3, and I better get the same y-intercept because they're on the same line. So we found out, and you didn't have to show me both ways. I'm telling you that when I do the answer key, I go both ways so I can see who, for whatever you guys decide to do, I have the work there to correct it. So this b is a 2, completing the equation, y equals 3/8 times x plus 2. That was horrible. And real quick, it's a little pet peeve. I don't think anybody in this class did it, but when you write the equation of a line, y equals 3/8x plus 2. And it looks like that x is in the denominator. It looks like it's 3/8x. So remember, it's 3/8 times the x, so the x needs to be like, either needs to be in the numerator or it needs to be just 3/8 in front of an x. So mx and then plus. That's the equation of line. Step by step, every single time. Step by step, every single. Remember that video I showed you about the drummers? It's practice. It is literally practice. Okay, until until you're doing it without looking up the steps, and you're saying the steps one step at a time in your head. Or if you don't need to say it in your head, you're just doing it. Okay, parallel and perpendicular. If they're parallel, their slopes will be equal. If they're perpendicular, their slopes will be opposite and reciprocal. And if it's not parallel and it's not opposite and it's not perpendicular, then the answer is neither. So you have to compare the slopes. To compare the slopes, y equals mx plus b. It's all about finding the slope. When you have the equation of a line, you need to get y by itself. You need y. This is the most important thing in section 1.2. That equation right there, slope intercept form, gives you everything you need to graph the line, gives you everything you're going to be able to write the equation line. In section 1.3 and 1.4, to change it into a function, it's got to be y by itself. So if I'm going to get this y by itself, this x has to go to the right side. So I'm going to add 25x to both sides. So I have a positive 45 times y equals, now it's mx and then the b. So I'm going to put the 25x first, and then I have a plus 10. And then to get y by itself, right now y is being multiplied by 45. Yeah, okay. Right? You okay? All right. So I'm going to multiply or divide everybody by 45. Because it's being multiplied by 45, everybody gets divided by 45. This one gets divided by 45. Whoops. 45, 45, and a 45. And then you got to reduce the fraction. Y equals 25 over 45. So 5 times 5 for the 25. 45, 5 times 9. And then you have your x. And then just so you practice, this is 2 times 5. This is 9 times 5. So the y is equal to the 5's reduce. You have 5 ninths x plus the 5's reduce 2 ninths. All we need to do, compare the slopes. So the slope of line 1 M sub 1, 5/9. That's slope line 1. So if it's parallel, the other slope, line 2, is going to be 5/9. If it's perpendicular, it's got to be opposite, so it has to be negative, and it has to be flipped, 9/5, negative 9/5, if it's perpendicular. If I don't get positive 5/9 or negative 9/5, then the answer is B. So remember, it's about getting the y by itself. So you can see it a little bit better. We're going to move it over to the side a little bit. I have 9x equal to negative 5y plus 20. And this, I know, not just this class, but the other class as well, mess people up when it's not on X and Y on the left side, but you got to like everything kind of scrambled around. But that's why I gave those 3 warm-ups at the beginning. All you got to do is 1 of 2 things. You can change it to standard form by bringing the y over to the left. Or you can just solve for y on the right-hand side and flip it around later. That's what I'm going to do. I got to get y by itself. Since y is on the right side, I'm going to get y on the right side. And if I need to, I'll just flip it like I did in the warm-ups. So to get this 5y, negative 5y by itself, I have to undo a plus 20, subtract 20, 9x minus 20 equals, that's, and don't forget the negative, negative 5y. Now, that y is being multiplied by negative 5. To undo that multiplication, we have to divide by negative 5. Everybody gets divided by negative 5. So we have positive over a negative. It's a negative 9/5 times x, a negative over a negative, that's positive. 20 divided by 5 is 4. Now, if that's not ringing any bells, if you're not seeing y equals mx plus b, it's because y is on the right. So just switch sides. In mathematics, if A equals B, then B is equal to A. It's property, it's a symmetric property of equality. So I can put y on the left side equal to, this goes negative 9/5 times x plus 4 on the right. So there's my y equals mx plus b. So the slope right here is negative 9/5. That's the slope of the second line. Positive, that's a negative, so they're not parallel, not equal. 5/9, 9/5, they are reciprocal. So line 1 is perpendicular to line 2 because, and if you didn't put this, I didn't mind, but in mathematics, what's the reason? It's where you get, that's the next step you have to take, because the slopes are opposite and reciprocal. Okay. We left off, he was going over 71, double check. 57. Measure. Wrong date. 57. Yeah. So after 57. No. 57. That was Monday last week. All right. We did 75. We did 75. All right. So we're moving on to this page right here, 77. Okay. 77, if you're worried about this one right here, it's actually not a huge deal. You're told the two lines are parallel. If the lines are parallel, the slopes have to be the same. They got to be equal. So you got a line, y sub 1, you got y sub 2 right here. What's the slope of the first line right here? Slope is equal to 2. This is where if you don't engage verbally, even if it's just, a small mumble to yourself, so I know you're out there, and, you say it to yourself, you hear it, you're the one speaking. You stay awake that way too. But that's the piece that you need to do. It's kind of like, you ever see like the movies where they do the brainwashing of the crowd, and everybody's like, I want everybody to do better. We want to do better. Yes, everybody must do this. We will all do this. The Simpsons. What is it? Bart Simpson. Don't blame the boy. And then don't blame the boy. You're just like, you got to kind of get into that frame of mind. So we're supposed to find the slope intercept form for the second line. So what we need for y sub 2 is mx plus b. First thing you got to find is the slope. If the slope of the first line and the parallel is 2, the slope of my second line is going to be 2. So y equals 2x, and now you just have to find b. Look at the picture. What is b for the second line? It goes through 4 for the second line. Right there, 1 is giving it to you. It shows you that it's going through y equals 1. Now, it doesn't have a big circle. But I'm predicting, so let me do this. I'm predicting that it's a plus 1. I'm going to do it in dot. And plus, it's going to be a 1. Just in case it wasn't a given picture. Because in mathematics, you can't assume. You can't. Okay? Do you know what the saying is? Never assume. Because when you assume, you make a. You know that saying? You make a. I learned that when I was 3. Roughing it. But what they do give you is a point. So if you know the slope is 2, y equals 2x, and I don't know what b is, but I know that it's got -1 on it. You plug -1 in for x, -1 in for y. Just like we did in the quiz. So -1 goes in for y. So -1 equals 2 times -1 is -2 plus b. Add 2. -1 plus 2 is 1. 1 is equal to b. Y equals 2x plus 1. Okay. And then 85. Have I told you about my son's best man? My son's best man skipped the 2nd grade. Right here. Skipped the 2nd grade. And he was in my daughter-in-law's, well, he was in my son's class and my daughter-in-law's class. They're all, graduated the same year. But my son, as a sophomore, was in calculus BC, and my daughter-in-law was in my honors advanced math analysis, and so was his best man in my honors advanced math analysis. So they're bright little jerks. Okay. His best man, Derek, went to Berkeley and got his architect degree, became an architect, and he did it in 3 years, which is just blew me away. So he's an architect in San Francisco. He's an architect in San Francisco, but he's kind of bored because there's not enough work to go around for everybody. And so in his boredom, he realizes, what else can I do besides being an architect? And he's always played fantasy sports. And not just fantasy sport, but real hardcore fantasy sport. Fantasy, football, baseball, whatever. But fantasy baseball, he not only played major league, but he played minor league fantasy baseball. So he saw a job position open up as a scout with the Los Angeles Dodgers, and he applied and he got it. As an architect degree, he's never played baseball past, I don't know, little league. But these days, it's about the metrics. It's about understanding the science that goes along with predicting what a player is capable of doing and being able to communicate with other people. Okay, that's what this kind of a problem is, how it works in the real world, the math that he was able to apply in the real world. Well, long story short, he was a scout for the Dodgers for the first year. I got to sit in the owner's box because he invited me to sit in the owner's box with him, watch a game. I met Don Newcomb before he passed away. Don Newcomb was an MVP pitcher, Rookie of the Year, and Cy Young Award winner back in the 50s, 60s. Amazing pitcher, amazing guy. But Dodgers lost that. At the end of this first year, this was 2017, they consolidated 2 scouting positions into one, and the guy with more seniority got it. So he goes back to his firm, who still wants him in San Francisco as an architect. Then next year, 2019, the Dodgers call him up. We need you to come back, but not as a scout. We want you back as an architect to do all of the renovations to get the stadium ready for the All-Star game, which was 2020. That didn't happen. It's supposed to happen this summer. But to also get our stadium ready for the Olympics, I think it's 2028. I think. Maybe I don't know, 2024. Whenever the Olympics, to update the look of the stadium, which now it's incredible. What you couldn't do was walk all the way around Dodger Stadium. Now you can. Extra elevators, all that stuff. He was a major part of it. And then when that project was over, and he was going to be like, all right, it's done. Have a good life. They said, no, we want to keep you on and send you out to other teams. So now he's like a subcontractor working to renovate Toronto Stadium, and he's working in Arizona to do spring training facilities, and it's all because you can understand and communicate the math. Communicate. You can't be silent. You got to be active. And you got to chase what you want to do. You can't let obstacles stand in your way. Okay, that's why obstacles are meant to be overcome. Okay. So here we go. The rise to run ratio, it's all about slope of the roof of a house determines the steepness of the roof. The rise to run. So this is the rise. Vertical is the rise. The run is across. Determine the maximum height in the attic of a house that is 32 feet wide. Now, that's where there's the misdirection. Do you understand what they're actually giving you? They're not giving you the actual number you need. They're giving you the whole width of the house, but here is the triangle. The ratio, you see this one is horizontal. This one is horizontal, so this is your 4-ish. And the vertical is your 3, that's your 3-ish. Now, when I say 3-ish, it's got to have the same ratio of 4 to 3 or 3 to 4. Now, if it's rise to run, if the slope is rise over run, in this case, the slope would be the rise is 3 and the run is 4. 3 over 4. Now, here's what you do know. If the entire width is 32, then that's not just 4-ish, it is exactly what? It's exactly 16, halfway. So the ratio of 3 to 4 is got to be, well, 16's got to be on the bottom, because that's where the run goes. Okay. And then the rise has got to be here. To get 4 to make a 16, you have to multiply by 4, makes it 16. So if you multiply the denominator by 4, you have to multiply the numerator by 4. So that would be 12, 12 to 16. And that's what they want. What is the maximum height? What would this H have to be? Now, you could also set it up like this. The slope is 3 over 4. You know that this run has to be 16. You're given that. You want to solve for H, you can cross multiply. 3 times 16 is equal to 4 times H. Divide both sides by 4. 3 goes in, or 4 goes into 16 4 times. 3 times 4, 12 equals H. Okay. The rest of it was 89 to 91, 89, 91. I don't know why I put 89, 91 cost. It was just 89, 91. Okay. So you pick 89 or 91. Let me read the question. You're given a dollar value of a product in 2015 and the rate at which the value of the product is expected to change during the next 5 years. Write a linear equation that gives a dollar value V of the product in terms of the year T. Let T equal 15 represent 2015. So in 89, short number 89, 2015, it was worth $2,540. And the increase is 125 per year, $125 per year. But in the number 91, in 2015, it starts at $20,400 and it decreases $2,000 per year. So that information is language that you have to interpret and make a word problem, the word problem into a math problem. So which one do you want, 89 or 91? If you don't choose, I'm gonna skip it. 89. 89. So they're done basically identical, except for one tiny little thing that I'll get to at the end. They say it's a linear. Linear means ordered pairs. T. So when T is equal to 15, V is equal to 2,540. So that means you have an ordered pair of 15, 2,540. That's what this is telling you right now. When T is 15, the Y value, the V value, is 2,540. Increase per year, that's a rate. Rate is slope. That's what a slope is. Slope is a rate of change. So the slope of this line is 125. So write a linear equation that gives a dollar value, V. So linear, V equals M in terms of the year T. So instead of Y equals MX plus B, the value is equal to M times T plus a B. Okay. We have the slope. D is equal to 125 times T. Just got to figure out the B. To figure out B, we need something to plug in for V and T. Well, here's the V and T. I'm going to let T equal 15 while V equals 2,540. So 2,540 is equal to 125 times 15 plus B. 1,040 is equal to 12,500, and then 5 times that is 625. So that's going to be 1875. All right. Plus B. Subtract 1875 from both sides. Borrow. Borrow again. 665 is equal to. So B is equal to 125 times T plus 665. Okay, you're given dollar value, the rate, so change it 5 years for a minute. That's it. That's all we want. Is the equation. So for 91, T is still 15. V at 15 years, 20,400. The rate 2,000, but what is decrease going to do? Minus the 2,000. So V equals negative 2,000 T plus V because it's decreased. That's like a depreciation when you buy a brand new car and drive it off the lot. As soon as you have that depreciation, it depreciates either a certain percentage per year or a certain amount per year. Property tends to go up and physical actual items tend to depreciate because they get worn out. Look at 95. Okay. Have you tried 95? You have? Tell you what, that'll be the first thing we do Wednesday, 95. Now that you've seen 89, 91, or at least 89, and then talk about 91, 95, and here's the thing is, students see a word problem and say, I'm out, I don't, as soon as I have to read more than like a sentence, no way. They tell you everything you need. Contractor purchase a bulldozer, 36,500. The bulldozer requires an average expenditure, and there's your rate, $11.25 per hour for fuel and maintenance. The operators pay $19.50 per hour. Write a linear equation giving the total cost of operating the bulldozer for T hours. So cost would equal how much you have to pay. What do you have to pay per hour? And then the equation total cost of operating the bulldozer, including the purchase price, and we can call that the purchase price, the initial price, and sometimes you can say that C naught, or NAUGHE, or nothing. The initial value. The initial value is just the y-intercept. That's your B. At time equals 0, how much did it cost you? $36,500. How much are you expending every hour? What's the rate every hour? Every hour you got to pay this much, and you got to pay this much. So the total expenditure per hour is basically 75 cents, and you've got $31.75 per hour for T hours, plus $36,500. Now, what are we doing? Here I am, I'm already doing the problem, so I'm just going to keep on going. Customers are charged $80 per hour. For the use of the bulldozer. Write an equation for the revenue derived from T hours of use. So the revenue is equal to $80 times T hours. Now, there's 0, at time equals 0, you're not making anything because you haven't charged anything. So it's just $80 for every 1 hour of use. Profit. Profit is equal to your R minus your C. Well, your R is ADT. Now, here's the most important part. Minus the cost. Your cost has 2 terms. So you need to make sure that you subtract 2 terms, parentheses. 31.75 T plus 36,500. So your revenue is equal to 80 T minus 31.75 T, and then minus 36,500. And then you have 2 like terms right here. Okay, so that's going to be $49.25. Revenue is equal to $49.25 for every hour of use, minus the initial cost of the bulldozer. How long does it take to break even? Okay. Oops, my bad. This is profit. This is How long does it take to break even? That's when you reach a profit margin of 0. When you finally have made enough money that offsets the cost of the bulldozer. After that, it's all profit. It's all positive. Because right now, if you only, I rent the bulldozer out for 1 hour, you're in the red because you haven't made enough money. So you let the profit equal 0, and you solve it. Add 36,500 to both sides. 49.25 times T is equal to 36,500. Divide both sides by $49.25. $741 hours, 741.11 hours. How many hours in a day? If I take that and divide by 24, I'll take 30 days.
So basically kind of like a month.
If that's going 24 hours a day. So let's say 8 hours a day. Okay. So it's 7, 4, let's go 7, let's round up, 742. And divide by 8 hours every day. So 92 days, about 30 days, or 92, 3 months, over 3 months. If you're going Monday through Monday, going 7 days a week, 92 straight days. So, maybe you go 5 days a week, maybe 4 or 5 months. But you got to have the work, the demand, supply, economics, all that stuff you might have slept through in high school. I don't know. I don't know if that's a good thing. You parents, those are classes we need to be teaching. Teach them how to write a check. Nobody writes checks anymore. Only Maverick writes checks his body. His ego writes checks his body can't catch. All right. 1.3. That's not a function. I finished watching 10 basketball. As a former, as a former, I don't care if it's or not. As a dad, there's a lot of dad stuff. I'm a sad. I cry. I don't hide. Marvel movie, I cry like 5 times in. Yeah, and I saw it like 6 times each time. 6 times shot, third time. So, my wife never cries. Really weird. I just had a recommendation from my son grad school. good man. He's a good father to that Corgi. All right, so functions. Think about functions. Function, right where we came from, ordered pairs. So it's going to be connected on with ordered pairs. Every set of ordered pairs is a relation. A relation between something from one set and something else in another set. So you have a set of things in the input and a set of things that are coming out of an output. You plug something in, something comes out, something goes in, something comes out. Those are all relations. Every set of ordered pairs are all relations. Special relations are called functions. Here's the mathematical definition. Okay. One of the reasons why I have a job is because people are not able to read mathematical textbooks. Because mathematical textbooks are written by snobby mathematicians who cannot write at a level understood by a normal person. A function f, so this script f is not a variable, it's a script f. It's just the name of this function. This is function f. You can have function g, function q, function r. In calculus, for position, it's called SOT, function position at any time t. Then you take the derivative of the position function with respect to time and use the velocity at any time of that position. V of t, which makes more sense. I don't know why they call position s, but anyway. Velocity is v of t, then take the derivative of that, and you get the change of the position with respect to time, which means it's the acceleration. The acceleration of any object at any time. So A of t for acceleration. But change of temperature with respect to time, or change of anything, miles per gallon. That could be a function. Okay. A function f, like Freddy, this is Freddy the function. From a set A, so some set of things, to another set. So it's matching things in this set to this other set, is a relation that assigns to each element x in the set A exactly one element y in the set B. In set A, you have a whole bunch of things to be in here, a whole bunch of stuff. Over here in this other set, where the y's are, the x's, or here are the y's. The connection between the x's and y's, they're all relations. They're all relations. If the relation is a function, then the x's from here over to the y's over here, each x has only one y value. Only one. So when you go from here to here, the x from here gets only one y. So that's what this means. Assigns to each element x in the set of A exactly only one y in the set of B. The first set A is the domain. The second set B is the range. The domain is what you plug in. The range is what comes out. We plug in something for x and we get a y value out. Ordered pairs, x's and y's. The x's are the independent variables. The x's are the independent variables. The y's are the dependent variables. Because you can choose whatever you want. X can be anything it wants, but as soon as you plug it in, y depends upon what you just plugged in. You can't figure out what y is until you plug in something for x. So x can be anything, and then y gets determined by what x is. Y depends on what x is. Simple examples of some functions. So I like what they do here because before we actually get into functions and plugging stuff in, they break it down into, here's when we talk about set, it's like a box of stuff. I mean, not just a rectangle of things, but you can think of it as a physical, three-dimensional, you have a box of things, a set of things, and in here is everything in the domain for the relation or the function, things that I'm going to plug in. And when I plug these things into my relation or my function, over here in this other box, the range, these are the things that are associated. These are the things that come out. And this is how it matches up. At this time of day, in the afternoon, this is how the temperature is going to be in Celsius. So at 1 o'clock, 9 degrees Celsius. At 2, 13. At 3 o'clock, 15 degrees Celsius. At 4 o'clock, 15. At 5 o'clock, it's 12 degrees Celsius. And then at 6 o'clock, it's 10 degrees Celsius. The first set is the domain. What times? 1, 2, 3, 4, 5, all the way to 6 o'clock. The output is the range. What came out now? There's all these other degrees Celsius, but these are the only ones that actually are related to the ones that came, the times of days. Okay. Ordered pairs. At 1 o'clock, it was 9 degrees. At 2 o'clock, 13. At 3, 15. At 4, 15. 5, 12 degrees Celsius. And at 6 o'clock, 10 degrees Celsius. The first coordinate input, second one is output. Is it an example of a function? Now, so every set of ordered pairs, always a relation. Always a relation. Special sets are functions. It's a function if the x coordinates do not repeat. You cannot have an element of the domain happen twice. The ranges can repeat all day long, but the domains can't. Is that an example of a function? So here's how you tell. Do you see any of the x values happen in more than one set of ordered pairs? Does x ever repeat? No. So if x doesn't repeat, you got yourself an example of a function. Now the y's repeat. Right here, we have 15 degrees and 15 degrees. At 3 o'clock, 15, 4 o'clock, 15, that's perfectly fine. The y's can repeat, x cannot. And here's the reason why, if you really think about it. If over here I put 1 o'clock again, at 1 o'clock it's 9 degrees, and over here at 1 o'clock it's 10 degrees. Make up your bloody mind. At 1 o'clock, do we get 9 or at 1 o'clock do we get 10? You can't have two different answers when we plug in 1 o'clock, 1 p.m. Now maybe it's, if they said 1 a.m. versus 1 p.m., then we have something different. That's why you have the 24-hour military time. Okay. But this isn't, it's all about PM. You can't have 1 p.m. give you 9 degrees, 1 p.m. give you 10 degrees. That would not be an example of a function. That's just a relation. Okay. Okay. Characteristics from set A and set B. Each element of A, everything in set A has to match to B. There has to be something in B. So you can't have an X value that doesn't have an arrow to something in B. So that would be kind of like, do you know what they say about Alaska? And I'm sorry this is going to sound sexist, but you know what they say about Alaska, the male to female ratio. You've never heard of this. The female ratio in Alaska is much smaller than the male ratio, because in Alaska, that is a very physical labor driven, area. So very physical labor driven, logging, things like that. That's why the population in Alaska, they say for every female, there are 3 males. Okay. So if the women represent the domain, then every woman should be able to match up with a man. And there's going to be some leftover men that don't get anything. But every woman should be able to match up with a man. Okay. I know it sounds, I'm sorry. It's the first thing that came to my head. My wife lives in that. My dad went to work in Alaska. No. Okay. Some elements of B, so in the range, you may not have something. Okay. Leftover guys. 2 or more elements of A, 2 or more elements of A may be matched to the same element B. So the range could have 2 different times. It was 15 degrees at 3 and at 4. So 2 or more elements of A could be to the same B coordinate, or the same element of B in the range. An element of A in the domain cannot be matched with 2 different B's. So let's make this real simple. Everything in the domain has to have somebody in the range, but not everybody in the range has to have an X element. The Y's can repeat, but the X's can't. That's everything he just said, right? Okay. If it's a function, if it's a function. If it's a relation, it's just sets of ordered pairs. So this is just about functions. Now, functions, if you're going from set A to set B, if you switch those and go B to A, then everybody's got to flip because B is now the domain and A would be the range. Okay? Which is what we do when we do an inverse function. An inverse function is what undoes the first one. So inverse functions are this. The first thing you learn how to do in math when you're first growing up, learn how to add. Well, I mean, you learn how to count. But then first grade, second grade, add. And then we teach you how to undo that, subtract. Then here comes multiplication. Okay, we're going to undo that, divide. Okay. Here comes squaring things. Here comes undo that, square root things. Here comes, let's take, in geometry, let's take the sine, cosine, tangent simply of an angle. But there are times where you have to take the inverse sine, inverse cosine, inverse tangent of a ratio and find out what the angle is, the inverse function of a sine. So in trig right now, the sine of a 30-degree angle is, and you punch that in, you get 1/2. But what if you're trying to figure out the angle? What if you want to know what is the angle? We call it theta in trig. Sine of what angle is 1/2? Well, you take the symbol is inverse sine of a half, and that will spit out 30 degrees. The inverse sine undoes what the sine just did. They undo each other. So that's when you would switch range to domain or domain, switch. And that's what inverse functions do, and that'll come up in, I believe, 1.4 or 1.5. So for the first example of this, I'm going to go to the homework because that's the best way to see some of these questions. I'm going to kind of walk you through some of these first, because it's 1 through 6 all. A relation that assigns each element X a set of inputs. The set of inputs is called the domain. Now, here's what's nice. Ordered pair, X and then Y, right? Alphabetically. Ordered domain. the x's, range is the y's, alphabetical D then R. Okay. Element Y is a set of outputs for the range, and a relation that assigns each element from a set of input exactly one Y is called a, this is a word. The formal name of Freddie, he's a function. Okay. This is where that vocabulary comes to speak the language. For equations that represents y as a function of x. So y is a function of x. That means like when you have y by itself, y equals 3x plus 2. Y as a function of x. So y is by itself. Y equals 4x squared minus 3x plus 8. Okay, that's a function. You know, that's a function of y. I'm sorry. That is y as a function of x, y by itself. Okay. The independent variable is a set of all x in the domain, and the dependent variable is a set of all the y's in the range. The independent is your x's, and the dependent is your y's in the range. Because now you're plugging in x's. And when you plug in an x, you find out what the y depends on when you plug in the x. And when you look at 3, you have an ordered pair, two ordered pairs, 3, 0, 3, 5. Could that relation of ordered pairs also be a function? No, because x repeats. When I plug in 3, I get 0, but later on, when I plug in 3, I get 5. We'll make up your mind. The same x cannot give me 2 different y's. All right. This is where, you know, I can't remember yesterday very well. I certainly was struggling with remembering what we did last Wednesday. Okay, that's just for, you know, you're reaching my age. Yesterday is hard. 30 years ago, not so bad. Technically, it's almost 40 years ago. Back in 1985, during the summer of 1985, I got a free 7-week course at UCLA. Okay, I went to UCLA for a year and a half. And before he started the freshman semester, they did something called the freshman summer program. And that was completely free. Go live in the dorm for 7 weeks, take a couple of classes, get acclimated to living away from home and all that stuff. Partying away from home. Partying away from home. We went to a lecture with about 500 students in it. But then the lecture is split up to your TAs, your teaching assistants. I had Matt, Don, and Daisy. I still remember their flipping names. Matt was a surfing dude. Basically, you know, his day didn't start until 10 or 11 o'clock. So he always walked in the flip-flop shorts and he came right in from the beach. And he explained what's going on in number 4. When you see function notation, like g of x plus, or right, g of x equals 3x minus 2. This is function notation. And what you're supposed to do is plug in something like evaluate g of x or g of 5. If I replace this x right here with a 5, then I replace all the x's with a 5. So g of 5 means it's now 3 times 5 minus 2. So g of 5 equals 15 minus 2. So g of 5 equals a 13. When you plug 5 in for the x, that's your domain. The range, what came out is 13. It's an ordered pair, plug it in. You know, if you plug in,
You put anything for the X?
you could plug in anything, because remember, what this is gonna replace, this is X's go in, what comes out are Y's. This is replacing, instead of Y equals, it's G of X. And it really makes simple, substitution a lot nicer to work with. In addition to this, the revolution the person who invented the function notation was Leonard Euler in the 1700s, late 1700s. Then you're able to do so much more with the calculus because the notation, just simplifies what you need to be able to do. Something like this. If you had to plug in -3, so now plug in something different. So 3 times -3 minus 2. So G of -3 equals -9 minus 2. So G of -3 equals -11. So when -3 goes in, we get -11. If you had to plug in the number pi, G of a pi, then if I replace this X with a pi, then all the X's get replaced with a pi. 3 times, this is 3 times pi, and then a -2. Well, that doesn't simplify. Because we want exact answers when we can get them. I'm not gonna make a substitution of 3.14 or 5.9. I just want X is pi, and the Y is 3 pi minus 2. So for the most part, our class, we got that. But what we didn't understand was when we had to do something crazy like this. Okay. So Matt said, all right, it's substitution. No matter what you replace X with here, you replace it over there. So if you wanted to go G of happy face, then you're replacing the X with a happy face, you replace that X with a happy face. This is now 3 times happy face minus 2. It doesn't matter what you plug in. If you want to go G of scary monster, well, that's just 3 times scary monster minus 2. It doesn't matter what you plug in. So when you have G of X, 3x minus 2, and you want to replace and plug in G of X plus 1, you are replacing that X with an X plus 1. That's what this means. Replace the X and call it X plus 1. So that means you're going to take this X and you're going to replace it with an X plus 1. Okay. Don't get frightened. Parentheses! Shall set you free. It is so important. I say this every semester. I say it almost every day. Parentheses, especially when you plug in 2 things, when you subtract more than one thing, when you do subtraction, parentheses. That X is 3 parentheses X plus 1 now, instead of 3 times X. That's now going to be your X, and then a minus 2. It just replaces whatever the X was. It's now an X plus 1. And now you distribute the 3. Yep. To simplify it, so G of X plus 1 is equal to 3x plus 3 minus 2. So G of X plus 1 is equal to 3x plus 1. That's what it equals when you plug in X plus 1. And all they want to know is, what do you substitute for X in this? I plug in X plus 1 for X. That's all they want to know. It's like, it was baffling to us. It was baffling. And then he said, oh, scary monster. Okay, I get scary monster. Oh, whatever I put in there, I just got put under. So if it was f of x equaled 4x squared minus 2x plus 8, then f of x plus 1 would be 4 parentheses x plus 1 squared minus 2 times x plus 1, and then a plus 8. Because each of these x's are now x plus ones instead. Okay. Now, these two are going to come around a little bit later. I'll come back to those. Because when you want to find the domain when it's written as a function, or you want to find it implicit, implied, sorry, is it implied or explicitly described? We'll go over that when we actually get to this question. I like raising my voice. Makes you think I'm coaching. When I teach statistics, or when we get to it in algebra 2, and we do something like, what does that mean? What is that? Right, exactly. Nobody knows. It's a 5. Is that what it means? 5. No, it's not. 5 factorial. Don't you see on your calculator a little button that has an exclamation point? Your calculator doesn't scream 5 at you. This notation means you go from 5 all the way down to 1. Well, factorial. But I get the screen.
What's that called again?
Factorial. 5 factorial. When you do probability, like how many ways can you arrange the 3? If I take the name of the band, The Who, how many different ways can you arrange those 3 letters? Well, there's 1, and then let's just do this. You can go HWO, you can go HOW. You can go WOH, okay? You can go OWH, and you can go, was it OHW? I forgot how to do them by hand. But there's 3 letters. So if you have 3 individual things, how many different ways can you arrange 3 individual items, unique items? It would be 3 factorial. 3 times 2 times 1, so that's equal to 6. So if you had, for me, I basically wear 1 pair of pants. I have about 4 shirts or 5 shirts. I don't know, 4 shirts. I have 2 pairs of shoes. So how many outfits can I make? So 1 factorial times 4 factorial times 2 factorial. Okay. I wear these pants with, and it's kind of like doing a chart like this. These pants with that shirt, that shirt, that shirt, that shirt, with those shoes, those shoes, those shoes, and then do another one, and it's going to be 1 times 4, 3, 2, 1 is 12 times 2 times 1 is 2. So that's 24 different. I'm good for a month without wearing the same combination more than once. Okay. You do the same thing if you have 3 flavors of ice cream. How many ways can you arrange an ice cream? Okay, all sorts of them. And then you get into in mathematics. I like to use this because there's a difference between permutations, which means order matters, and combinations, which means order doesn't matter. Permutation would be like a batting order. You have 9 players and you got to put them in order. So 9 players, you have 9 choices, 3, 4, 5, 6, 7, 8, 9. You have 9 choices for the first batter, then you're left with 8, then you're left with 7, 6, 5, 4, 3, 2, 1 choice. Pick last, which is usually the pitcher.
So if it's 9, you go from 8 to 1 and then add them together.
Multiply,
Oh, okay.
multiply. So there's 9 people here that can connect to 8 people here, 8 different ways, that can connect to 7 people left over, and so it's multiplication. So it's 9 factorial different ways you can arrange batting order. But on a basketball court, order doesn't matter. You just sit 5 starters and they run out there any way you want. So that's a combination. And so a combination of 5 players taking 5 at a time is equal to 5 factorial divided by 5 minus 5 factorial times n minus r times n.
Were we supposed to learn this in high school?
No, if you took stats.
Oh.
And sometimes if an algebra 2 class can get to it, they get to it. So the number of choices when it's just combination just run on out there, not that much. Did you do 9 factorial?
Yeah.
With,
Well, I just do it.
oh, with the doing it. It's like 300,000 something.
352,000.
That's how many different ways you can arrange a baseball's batting order with 9 players. And that's only considering the 9 starters you've chosen. That's not considering everybody that's on the team. When you consider 9 players out of 25 that's on a roster, it's much higher. For just the batting order. Okay. Back to our regularly scheduled. See, I remember walking around UCLA and getting a decent grade on a test, feeling pretty good about myself, because I'm thinking, wow, there can't be anything more than this. My brain hurts. There cannot be anything more than what we just covered. Everything else must be like, you know, piece of cake or is just review. And it's like, if you've ever gone hiking and you're climbing a mountain, and you think it's a mountain, but it's just a hill that hides a higher mountain because you can't see over that first hill. Math, when you're doing a class, it's like this hill is just hiding a higher mountain behind you. So you climb to the top and there's something else. You climb to the top and there's something else because it branches off into so many different ways.
Do you teach 4A too or no?
Yeah, my 4A. My 4A, 3A. That's as high as I'm going right now until we get more students taking the higher levels here.
Gonna be summer, huh?
Friends said a long time ago, friends don't let friends teach summer school. But I taught summer school. I did my time. I did it year after year after year. My body can't take it anymore. That's the truth. And it doesn't matter what order you take them. I have some students that are taking 4A and 3A at the same time.
You can do that?
Because 4A is just focusing on the trick. Just the trick, same textbook. They're just doing the trick. So they start chapter 5. And there's not really anything from the previous chapters that they need to do in those chapters. Just like you don't need to worry about anything in those chapters to do these chapters. Yeah. Yeah. I don't think my counselors realize. I know it's like 3A, 4A, 3, 4. We've got to number them. So it's like, you know. All right. It's a relation, does it describe a function, number 7? So what we're looking for, if you are going to do this mathematically, domain and range ordered pairs. So -1 is mapped over to 8. 0 is mapped over to 6. 1 is mapped over to 6. And 2 is mapped over to 7. Do any of the x coordinates repeat?
No.
No. The y's are fine to repeat, but the x's can't. Therefore, that's a function. And one other thing, do all the x's have a y? Yes, they do. So what you're looking for, do any of these domain values have 2 arrows coming out? or more. So if there was -1 also went to the 6 as well, no longer a function. Okay, because -1 cannot equal 6, and then -1 can't give you an 8 as well. And we use 10 as an example, or let's just go to 9 because it's super boring. So we've got the NFC. See, this is what, when I first looked at this, I thought in the domain there were 3 things for a second, just because when you first glance at it, you have 3 rows, national, football, and the conference. I thought there were 3 things over here. And then the arrows are only coming out of one of them. But this is just NFC. And over here, this is just the AFC. Is that a representation of a function, yes or no?
Oh,
No.
that one.
Yeah, see, the NFC is your domain, and it goes to the Giants. The NFC is your domain, and it goes to the Saints. And the NFC goes also to the Seahawks. Oops. I used to draw Seahawks a lot better when I was in the 2nd grade. Or Seagulls. Right. So it's going to 3 different things, not a function. And the AFC is going 3 different things as well. Sorry, no problems. You got the Super Bowl. I got Dodgers. Dodgers going to win the Olympics. Dodgers going to win the Super Bowl. Dodgers going to win House County Cup. Dodgers going to win the NBA. So, is it a function? Yes or no? Here's the inputs, home domain. Here's the outputs, the range. Do any of these X's repeat? Nope. Does every X have a Y? That's a function. Look at 12. Do any of these X's repeat?
Yeah.
And they have different, so that's not a function. Okay. This is a good representation of the next little tool that you have, number 13. So this is a scatter plot, a whole bunch of dots, ordered pairs. And again, ordered pairs of points. Would that scatter plot of points represent a picture of a function? No. If you just labeled, like this guy right here and this guy down below, when X is a 2, this Y is a 3, but down here, when X is a 2, the Y value is a -1. So when X is the same number, 2, we get 2 different Y values. X repeats, not allowed. But you can also use this test. It's called the vertical line test. The vertical line test. You either pass the test or you fail the test. If a vertical line intersects a graph in more than one place at a time, not a function, you fail the test. If it only intersects a graph at one time, or at most one time at any one place, then you are a function. So what that means is if you intersect twice, that means you have to have an X coordinate that's the same. If it intersects 2 points at the same time, you have the X coordinate the same. Over here, all of these points don't have 2 points on the vertical line. So that's a picture of a function, it's a yes. And when it says explain the reasoning, you could just say, some of these points have the same X value. Over here, some of these, when you're not doing this one, none of these points have the same X value. Or X repeats, or X doesn't repeat. Okay, all the way to 47 on. Now, I'm gonna do 16, that means you want to do 15. 16 and 15 are very close. I like 16 because the one set is just an A, B, and a C. So we can, I think, okay, well, let's wait a second.
What's the markings?
I was gonna say, Loch Ness Monster, but she's not in a C, she's in a loch. Which I guess in Scotland, that would just be like a loch. So the first set, and they want to know which sets of ordered pairs represent a function from A to B. So you plug in A, you get a 1, plug in the C, you get a 2, plug in the C, you get a 3, plug in the B, you get a 3. Is this an example of a function from A to B?
Like 50 C's.
You have that domain value, because from A to B, that means A is the domain. That C is in 2 different ordered pairs. It can't repeat, so that's not a function. And then B. When you get A, you get a 1, you get B, you get 2, you get C, you get 3. Is that an example of function? Yes. And then for C, when you plug in 1, gives you 0 gives you 2 gives you a C, and 3 gives you a B. Is that a function? Yes, it's a function, but the question says, is it a function from A to B? No. Because the domain, the 1, 0, 2, and 3, that's B to A, and it's technically not even a function from B to A, because if it was B to A, that's every element of B. Everything in B would have to have a Y coordinate to it. So those 3 answers that we got, yes, it's a function. No, it's not a function. And yes, it is, but it's the other way around in some way. Those are the same things you're going to get in 15. Okay? But you could also go that if you look in the back. You look at the answer. Okay.
You did say homework is due when it's test day, right?
And the day of the test, yeah. So that, I haven't even set the testing. You will know when that day comes around, when it comes around. 3 days. All right, this is where I went away from the notes so I could give you an example right here. Determine whether the function, whether the equation represents Y as a function of X. So now you're not looking at a picture, you're just looking at an equation. Is Y a function of X? So back to, you look at the text. Text itself. To determine whether Y is a function of X, try to solve for Y, get Y by itself in terms of X. Get Y by itself and X on the other side. So this first one, if I'm going to get Y by itself, you have to subtract X squared from both sides. And so you get 1 minus X squared. 1Y is equal to 1 minus X squared. Y is a function of X. If I plug in an X value, there's only one answer for Y. If I plug in 3, I get 1 minus 3 squared. If I put X equal 5, for that one value of X, 5, I get one value of Y. I don't get 2, I get 1. That is a function of Y with respect to X. Yes, that is. And then you get something very similar. So X squared plus 1. This one is negative x plus y squared. To solve for y, to solve, gotta add x, 1 plus x, both sides. Now you have y squared equals 1 plus x. To solve that, y squared. Right here, they've added x. Y squared equals 1 plus the x. To get y by itself, you have to undo a square, so you take the square root. Now remember, the special word is, solve. Okay, solve. When I solve and I take the square root of both sides, I want every possible answer when I solve. So when you solve by taking the square root, you have to put plus minus. Here's the deal. If you were given this problem and it just said, what is the square root of 36? Well, the answer is 6. What is the square root of 36? The answer is 6. But when you were given an equation, x squared equals 36, and you want to know what's the answer, you're supposed to solve and get all possible answers for the x. This one doesn't, it's not an equation. This is just what's square root of 36, 6. But when you're solving an equation, we want everything that I can plug in for x that makes this true. So when you have a square root,